Ever wonder how we build our modern world? Well, it all starts with understanding the very stuff it's made of. And we can kick off that whole journey with a really, really simple question. Seriously, think about it. You're surrounded by more water than you can possibly imagine, but you can't drink any of it. So how do you get the salt out of the water? The answer to that simple little problem is actually the key to understanding the fundamentals of, well, everything. So to figure out our saltwater puzzle, we've got to zoom out a little bit. We need to ask a much bigger question. What is all this stuff around us? It turns out it all comes down to one really basic idea. And that idea is matter. It's a simple concept, really. If it takes up space, if it has some heft to it, it's matter. Your phone, the air you're breathing right now, it's all matter, built from these teeny tiny little things called atoms and molecules. Now, this matter isn't all the same, right? It shows up in different forms or states. The big three you probably know are solid, liquid, and gas. And in our ocean problem, we're dealing with two of them, the salt, which is a solid, and the water, which is a liquid. Knowing this is the first step to figuring out how we can pry them apart. Okay, so we've got our solid and our liquid all mixed up, but does that mean they're stuck that way forever? To answer that, we need to dig into how matter is organized and the different ways it can change. And right here, this is the crucial difference. A chemical change makes something totally new. Think about burning a piece of wood. It turns into ash and smoke. You can't unburn it. But a physical change, like ice melting into water, is just a change in form. You can pop it back in the freezer. And that's our secret weapon. Mixing salt and water is a physical change. That means we can reverse it without some crazy chemical reaction. So let's get even more specific. What are the absolute basic ingredients? Well, the simplest is an element. Think of it like a primary color, like pure red. You can't break it down into anything simpler. Gold is just gold. Oxygen is just oxygen. That's it. Now, if you take those primary colors and chemically lock them together, you get a totally new thing, a compound. Water is the perfect example. You take two hydrogen elements and one oxygen element, and you don't just get a mix of the two. You get H2O, a brand new substance that's completely different from the parts that made it. And this brings us right back home to our ocean water. See, it's not an element and it's not a new compound. It's a mixture. The salt and the water are just hanging out together. They're all mixed up, but they haven't chemically bonded to become something new. That is the key. That's why we can separate them using physical methods. So let's just lay it all out. Elements, they're pure, you can't break them down. Compounds, they're chemically bonded, so you need a chemical reaction to split them. But mixtures, they're just physically combined. And that last row right there, that's our in. That's the vulnerability we were looking for to get our fresh water. All right, so we've identified our target. We know salt water is a mixture, and we know we can separate it physically. Now for the really fun part. How do we actually do it? Let's open up the scientist's toolkit. Okay, this is it. This is the moment we've been working towards. We have all the theory down. It's time to put it into practice and finally get that glass of fresh water. And the answer is a beautifully elegant process called distillation. Here's how it works. You heat the salt water. Now, water boils and turns into steam at a much lower temperature than salt does. So the water evaporates, leaving all that solid salt behind. Then you just capture that steam, cool it down so it turns back into liquid, and collect it in a new container. And there you have it. Pure, clean, drinkable water. Of course. What about all that salt we left behind? We can get that back too. If you're in a hurry, you can just boil off all the water really fast. That's evaporation. But if you've got a little patience, you can let the water evaporate slowly. Do that, and you get these perfect, pure salt crystals to form. That's crystallization. You know, this whole idea of separating mixtures isn't just some neat trick you do in a lab. It is one of the absolute cornerstones of our modern world. It's happening all around us on a massive scale. I mean, just think about it. The gasoline that powers your car, the clean water from your tap, the sugar in your coffee, even life-saving medicines. Every single one of those things depends on these exact separation techniques to exist. They are the invisible processes that make our lives possible. Take fractional distillation. That's just a super-powered version of what we did with the salt water. But instead of separating out salt, it separates raw crude oil into all the different fuels that power, well, everything. It's absolutely essential. Or how about filtration? That's another physical separation method, but this one is a literal lifesaver. Water treatment plants all over the world use it to remove dangerous stuff from our water, making it safe to drink. A simple idea that saves countless lives. Okay, so you did it. You distilled your water, you crystallized your salt, you've got your separated substance. But how do you know? How can you prove to yourself and to everyone else that what you have is actually pure? Well, this is the really beautiful part. Every pure substance has a unique fingerprint, a totally fixed melting point or boiling point. Pure water, for example, always boils at exactly 100 degrees Celsius at sea level. If your separated water does that, boom, you know it's pure. If the temperature is off or it wavers around, you know you still have some impurities in there. It's a simple, perfect test. So there you have it. We started with a simple question about salt water, and it led us all the way to the fundamental rules for building and refining our entire world. This ability to separate mixtures, it's about the power to analyze, to purify, to create. You've got the basics now. So the question is, how will you see the world differently?